Yes, so this will be notes, okay? So we're just going to title our notes here real quick, and it won't be very much, I don't think. We're just going to take a look at, like I said, 2 postulates. But these postulates, well, they're postulates that, and what does it mean to be a postulate, right? It's something that we just kind of agree upon to be true. So it's something that, hopefully is just what we would call maybe common sense. So that, yes, of course this thing should be true. So the first one we're going to look at is called the Ruler Postulate. Okay, and then we're also going to look at the segment addition. Okay, postulate. All right, segment addition postulate. So 2 postulates, the Ruler Postulate and the segment addition postulate. All right. And so, remember when we talk about postulates yesterday, if I can just look real quick here, okay? We said postulates, or I told you guys what postulates were. They're statements that just are assumed to be true without proof. So we don't, need to, necessarily show that they're true. We just kind of assume them to be true. It's kind of like ground rules. We just, agree, yeah, this thing it really needs to be true. If this thing's not true, then we're kind of, stuck, so to speak. Okay, we can't really do much. All right, so the 2 postulates, the Ruler Postulate and segment addition postulate, okay? And so the first postulate we're going to talk about, we're going to talk about that Ruler Postulate, and it's so simple you might not even think that really it needs to be stated, but we'll state it. Okay, so the first kind of ground rule that we kind of just agree upon, we'll say stuff like points, okay, on a line, all right, can be given coordinates. Points on a line can be given coordinates. And that barely fits there. Okay, there we go. Okay, points on a line can be given coordinates. Now you might be wondering, why do we call this the Ruler Postulate? If we are saying points on a line can be given coordinates. Well, if you look at a ruler is not really a line. We might more think of it as a line segment, right? Because it has kind of a starting point and a stopping point, right? You guys wouldn't be able to carry an infinitely long ruler in both directions. But if you think about it, okay, so it's got a line segment here. And at particular points along this line segment, there are little tick marks, right? And those tick marks, so for example here, at this tick mark, it's got a label of 0. That means at this tick mark, right, we can say it's got a coordinate of 0, right? And at this little tick mark here, okay, a certain distance away, we give it a tick mark, the big tick mark right here, we give that a 1. So we say that has a coordinate of 1. And then a little bit further away, coordinate 2, 3, 4, 5, 6, 7, 8, so on and so forth, okay? So that's why we call it a ruler postulate. A ruler is basically a line segment that has coordinates on it. You probably never thought of it that way, but these are all coordinates on our ruler here. Not just measurements, but they're also coordinates. So as an example, we can also look at an example in kind of more abstract terms. All right, so if I draw, for example, a line here, all right, and I can put some points on here. So that's point A there. We'll put point B over here. And I'll say that A has coordinates of 2, and I'll give B coordinates of 10. All right. What then if I have A has a coordinate of 2 and B has a coordinate of 10? So I want to raise your hand and tell me what's the distance between A and B. What's the distance here? 8. How'd you get that? 2 plus 8 is 10. It takes us 8 to go from the 2, our starting point there, up to 10. That's right. Alternatively, you could also do 10 minus 2, right? And some of you guys are thinking, come on, Mr. Wood, are you serious? This is so easy. I don't know why. But again, it's not, this is important, all right? You're right. It is kind of basic, but it's also important. So yeah, we can find distance, okay, or the length, whoops, okay, of AB. And notice how I'm naming it, segment AB, right? We can't measure the distance or the length of a line. Why can't we measure the distance or the length of a line? Because it's infinite. It goes on forever, right? You can't talk about something because it's infinite. That's what you say. You don't have to measure it. It's like, oh, it's a line, it's infinite. Okay? But the distance or length of segment AB, well, 2 to 10, again, we can, yeah, it's 10 minus 2 equals 8. Okay, 10 minus 2, which is 8. Another way we can say that, instead of saying this whole big phrase here, so, you know, in math, we like to, make things as simple as possible, or make it as, as concise as possible. You put a little m next to the AB like that, and that stands for the measure of segment AB, and again, that's 8. Okay, so that stands for measure of. Okay, that's a little m, stands for measure of segment AB. And then sometimes, to make things even more confusing, sometimes we just say just AB with no segment above it. And again, that means the same thing. Okay, so when you see AB, no segment above it, it just means the length from A to B like that. Or again, the little m next to AB. I normally use this way. Okay, that's part of the problem with geometry, is like there's sometimes more than one way to ask for something. I will normally write it this way, but sometimes you'll see it this way too. And again, if you're unsure, you can ask and I'll clarify. Okay. But the key thing to remember here is that the distance, okay, on the line is the difference, right? Difference means subtraction. The difference of the coordinates. Okay, whoops. Okay. That's what Alex was saying. Can I say Alex? Is that okay? Okay, I don't know. Some people don't like it when you shorten their name. I have a friend whose parents get very upset his name's Michael, I call him Mike, but his parents get upset because their parents are like, I named him Michael, you call him Michael. So I was like, all right.
How does he feel about that?
He will let people call him Mike when he's not around his parents, and then he says, you should probably just call me Michael when he's around his parents. So, so there you go. All right, next one. Segment addition postulate. Whoops, I'm running out of space. I'll do it down here. And again, from the words, you can kind of figure out what we're going to be talking about here. We're going to be adding segments together. Okay. So you can kind of see we're having some arithmetic come in now. We see numbers, we're subtracting, okay? So some of you guys maybe were thinking yesterday, it's like, where does the actual math come in? Well, geometry is still math, even if it's just pictures and things, and, we're just identifying things, but you think of math if there's numbers, I guess, right? And so now it's more math-like, okay? Segment addition postulate, though, if A, B, C, okay, are collinear, then the measure of segment AB plus the measure of segment BC, okay, is equal to the measure of AC. You might be like, what? And I'll draw a picture here. It'll make more sense when you see the picture, okay? If A, B, and C are collinear, then the measure of AB, segment AB, plus the measure of segment BC is equal to the measure of segment AC. And here's a picture of that. So I need to draw, first of all, for this picture needs to have A, B, and C collinear, so all on the same line. So I'll draw a little line here, and I'll put A, B, and C in that order. If you don't put them in that order, it does kind of mess things up. So you do want to make sure they're in that order for this purpose. Okay. And so you see a line here, but within this line, there are line segments, right? AB, that's a line segment. BC, that's a line segment. Okay? And so this, from here to here, that would be the measure of AB. Right? But then from here to here is the measure of BC. Right? And if we take that measure of AB, if we take that measure of AB and we add to it the measure of BC, shouldn't it equal the total AC? Yeah, exactly right. It should. It should add up to be the total there. Okay, so part plus part should equal the entire or the whole piece. Part of the entire piece plus the other part of the entire piece should equal the whole piece there. Okay, question?
So like taking off like never mind.
Okay, no, I mean again, if you figure out what you wanted to say, that's fine. We'll do some more problems with it too, so you can kind of get a better idea. Okay. All right. So questions on that? Oh, yeah, sorry. Yep. So we're going to actually look at a few problems here. We're just going to just see how we're going to put this into play. All right, to get an idea here. We're going to use this segment addition postulate. And again, it's a postulate. This is not something that's proved to be true. It's just kind of like, well, if this isn't true, then we're kind of going to be in trouble. So we need to assume that it's true. All right? If this were not true, then we'd be like, whoa, I don't know what that kind of would look like. We want it to be true. We're just going to say it's true. All right, so our first example here, I'll start out by drawing a segment. All right, and sometimes I like to draw things in kind of like funky orientations because we get so used to seeing it drawn one way, and then when we see it drawn another way, you're like, whoa! You know, so that's why I'm trying to draw it funky like that. All right. So let's see here. I have points C, D, and E on a line segment, or two line segments, depending on how you want to say it. Yeah. So, and then I'll give you some measures here. So let's say that the measure of CD is 11. Let's say the measure of DE is 18. Okay. CD is 11, DE is 18. And I want to find the measure of CE, the full piece there. Okay, now, if I give you a problem like this, right, for like a warm-up or something like that, this is a place where I would ask you or expect you to kind of like draw this picture on your paper, okay? Now, obviously, we're taking notes, so you should be writing on your paper anyway right now, but like on a warm-up or something like that, you definitely want to write this down because the very first thing you should do, and the thing that like we can do in geometry all the time, is label your picture. All right, now some of you guys can maybe just look at this and say, the answer is blah, blah, blah. Okay, and that's great. That's great. But if you get stuck on something and you're not sure where to go, always start by labeling that picture. So, CD has a length of 11, so I'm going to go ahead and just like put that from here to here is 11. All right, and then from D to E, that length is 18. All right, and then so to get this full length, what does it make sense to do here? Add, right, yeah, add 11 plus 18 to get the full length, which is 29. You got it. Good job. Okay, exactly right. 29. Boom. All right. All right, I'm going to do another one, and I'm going to have you guys try two on your own. Okay, so I'll do one more together with you, and then I'll have you guys try two on your own. And then that'll be it for the notes. Okay. All right, next one. All right, draw a picture here. All right, so we're going to have F, H, and G now. I'm going to say the measure of segment FH is 17. The measure of FG, I'm going to say, is 40. And then the measure of HG is what I want us to find. Okay, that's our blank question. Do you have a pass? Okay, then yeah. Just show me the pass real quick and then you can head out. Okay, very good. We'll see you. Alright, so I can scoot that up some there. Is that okay? I'm not blocking, I mean, everyone can still see that, okay? So again, you look at this, and you might say, oh, this is easy, Mr. Wood. It's just like the last one. You did 11 plus 18, it's 29. So here, 17 plus 40, so the answer should be 57. Right? No. No, it's not. We got to draw, label this picture here. So let's see here. FH, 17. From here to here is 17. All right. FG, though, now FG, this is different. F to G is the full segment. It's the entire piece here. This is different problem. This is slightly different than the one we did before, okay? So I get it. That's good. We train you guys as, math students to kind of look for patterns and like see patterns. And you think, okay, I got this way, and then I'm going to do it the same way here. Well, kind of the same way, but not exactly. Okay? So you can see here very clearly, if we're trying to find from H to G, okay, we are not going to do 17 plus 40 here. What should we do? Yeah, 40 minus 17. Subtract them. That's right, subtract them. 40, take away 17 here. The big whole piece, subtract off the little piece, will leave us with what's left over there. And so that is 23? Yeah, okay, thank you, 23. Okay, so be on your toes there. I'm not trying to trick you, all right? But don't just assume, right? Label that picture. Label that picture, okay? If you don't label the picture, you're only hurting yourself. All right, label that picture. It's going to help you. All right, so I want you guys to try these two. All right, and just get as far as you can in them, okay? I'm going to throw some variables at you, so just get as far as you can with these problems here, okay? Not all of them have variables, but one of them's going to have variables in it. So again, just get as far as you can with it. Try and just set it up if you can, or whatever. All right, so there's our first one here. And I'm going to say that the measure of ij is equal to 5. And the measure of jk is equal to 17. And then I want you to find the measure of ik. And then I also want you to try this one. Okay, and we'll say that the measure of Lm is 2x, and the measure of Mn is x, and the measure of Ln is 15. What does x equal? Okay, so go ahead and try, set those up, solve for those blanks there. Okay, and the first one you're going to solve for ik, and the second one you're going to solve for what the value of x is. What the value of x is. What is that value of x? So some of you guys that like algebra, do a little algebra here. I come around and help as necessary. So you get stuck on something, you're unsure about it. You want to see if it's like right the way you set it up. So if that's 5, what could you now say is the length of Lm? Say the length of Mn. Okay, when you add x's, if I have 2x and I add to it an x, what's if I have 2x's and I add an x, how many x's do I have? Okay, sorry, what you did is you did 2x times x, that gives you 2x squared. Okay, yep, that's good. Good job. Okay? Good. Good job there. Yeah, that's right. Do you want the lengths for Lm and Mn then? Did you know that x is that value? What's the length of Lm have to be now? What's the length of Mn have to be?
30 more seconds here. We'll go over 30 more seconds. Okay.
So, what is the relationship when D between those three pieces of information? You know, just like in number one, we're able to say, like, for example, that IJ plus JK has to equal the total I X, right? So what would you say here? Okay, don't worry with the X's, just say the pieces. What piece plus what piece has to equal what piece? Okay, so there it is. But instead of LM, what do we know LM is like this? 2x. Well, we know NN is like this. So 2x plus x has to equal, well, has to equal L, yeah, it equals 3x. Equals 15. So let me show you again. You said LM, right, plus NN equals LM. LM is 2x plus NN, x. Okay, so 2x plus x has to equal the total LN, 2x plus x equals 15. Equals the whole. You see what I'm saying? Okay, so write it down. You can just write 2x plus x equals 15. I mean, you can write that part down too, that helps. Okay, so solve that. Right? Right? But if you're right, if you add a little geometry component in, like add a little twist to it. Close. This piece is 2x. This piece is x. So it's not just 2x that equals the full thing 15. It's 2x plus x, so it's 3x. All right. Let's go over this here.
All right. All right. And don't worry, guys. I will get names down. I promise. All right. Mitchell. Number one there. What'd you come up with for IK? 22. Yep, that's right. Okay, so that was IJ there is a length of 5. J to K is a length of 17. And so then the full length here, IK, well, that's going to be the 5 plus 17, so 22. You add them together. That's right. All right. Questions on that one? All right. Cool. Let's try the next one here then. All right, Deborah. Number 2. How'd you set this one up? 2x plus x. 2x plus x equals 15. Beautiful. Exactly right. Okay. So again, label your picture. If you weren't trying to do this, you better have labeled your picture at least. From L to M, that's 2x. From M to N, that's x. And then from L to N, 15. So piece plus the other piece has to equal that entire length. 2x plus the x equals 15. All right, I know that when you start throwing variables in there, that confuses some people or kind of like messes you up. You're like, oh, I'm not really sure now. But it's the same thing as what we did right here. 2x plus x, what does that equal? 3 x's, right? If I have 2 x's and I add an x, I now have 3 x's, right? 3x equals 15. And now we have a very simple equation to finish solving here. What do we have to do to both sides? Divide by 3. You got it. X is 5. All right, now, we have to be careful here. Here, when I got my answer of 22, that was the full length of IK. That was the full length, IK 22. 5, is that the length of LM? Is LM 5? No. Is MN 5? Yeah. Okay. Why is that? Well, MN is x long. What is x? X is 5. Okay. LM is not x long. It's 2x long. So what does that mean LM's length is going to be? 10. Okay, that's right. So this is going to be 2 times 5, or 10, and this is going to be 5. Okay, so now granted, we weren't asked that. It was just asked to find x. So if all you did was find x, that's good. But later on, okay, like well, possibly in your assignments or something like that, you could be asked to find the length of these 2 segments as well. Okay, so first you have to find x, then you can find those segments. Okay, questions on any of that? All right. So let me give you guys your assignment, and you can get started on that, okay? If you didn't